Hello, this is Rebecca Hadi, and I'm going to be demonstrating my code. So here, to load all the functions that I put together in an IPython environment, I'm going to run everything, but I'll step through step by step. This is almost done running. Okay, so the first thing I'm going to do here is load in the data frame, and then I'm going to demonstrate the imputation of missing values. Because I'm using the abalone dataset, it didn't have any missing values, so I'm just going to select set1 equal to none. And then I can test that that worked, and I also want to compute the mean. Then what I want to do is use the function that I wrote to handle missing values, and I can see here that this, if I run this again, it's been imputed with the mean. I'm going to handle categorical data with a function I've written to do one-hot encoding on sex, which is nominal because it doesn't have an order. So you can see here, I have created these 3 additional columns. I do have an argument here where I can drop this original column. I have it set to no drop right now. Next, I'm going to discretize the values based on length, and I'm going to use the equal size bin. So then I can tell here that all the bins are relatively the same size based on the number of bins I input, which is 5. Next is doing the standardization. So I'm just going to create a train data frame, 80-20 split, and a test data frame, and then apply the standardization on length. And I'll take the mean and standard deviation from the test data set, or from the training data set, and apply it to the test data set, which you can see over here. Next step is to do the k-folds cross-validation, and I'll be doing it for both the regression, for more average prediction for length, and then classification for the sex variable. So running here, what I can see for the size of it's a little bit embedded here within the warning messages, but I can tell here that these are roughly the same size. So fold 1, training set 3341, 3342, 3342, 3342, and then similarly 835. The mean squared error for each of these is around 0.013. And then what I'll do is I'll go down here to where I calculate the average across all the data frames. So I can see here that the average across all 5 folds for the mean squared error for length is 0.014. I can do the same thing for the classification, and here in the classification I want to maintain the proportion, so that's set up with this classification function. Again, you can see the size 3342, 3343, 3343, 834. And here I chose the classification accuracy, which is the number of correct predictions over the total, which are around 36% for all the folds. And similarly, I will take the average of all of them, and I get the average classification score as around 37%. So that was the demonstration of the different functionalities requested by the homework. Thank you. Bye.